Now let's look at the file streams. File streams are primitive streams whose sources and destinations are files. That implies that you may read or write to files. Files and directories are accessed and manipulated via a class called java.io.file. The base file stream classes in java.io package are file input stream, which reads binary data; file output stream, used for writing binary data; file reader; and file writer, used for character input and output. An input stream from a file can be created with the below code. You may first construct a file object saying file filein is equal to new file, passing the file name data.dat, and further pass the file object to the file input stream constructor. As you see here, file input stream in is equal to new file input stream file_in. Similarly, you may also construct a file output stream object. Here I have first created file_out is equal to new of file, passing temp.dat, which is a file name, and further pass the file object to the file output stream, saying file output stream out is equal to new file output stream file_out. Output streams to files are wrapped with one or more other streams to obtain greater functionality, such as buffered output stream. This is how we do that. First, create a file output stream object saying file output stream if out is equal to new file output stream, passing the file name. Further, construct a buffered output stream object, passing the file output stream as a parameter. If you intend to append an existing file, use the overloaded constructor and pass the argument true. By default, it is false. By default, file output stream object creates a new file. If your intention was to overwrite the existing file, then you may go ahead creating a file output stream object without passing a true argument. But then, if your intention was to append to the existing file, then you need to pass the true argument. Now let's look at an example. In this example, I am importing a file input stream and two exception classes, file not found exception and IO exception, as you see at line 1, 2 and 3. Further, at line 12, I have created an object of file input stream passing a command line argument. The statement could throw a file not found exception if the file name provided as command line argument was not found in the current path. And therefore, I have a catch block to handle the file not found exception. In case the command line argument was not passed, the statement would throw an array index out of bounds exception. This is the code to handle the array index out of bounds exception. At line 24, I am reading the data from the file. The method read returns a int value, which can be converted to a char, as you can see at line 25. Here we are typecasting the int value to a character type and printing the same in a system.out.print. The method read returns a -1 indicating the end of file. Therefore, we are checking the condition I not equal to -1. The methods read and close can throw a IO exception. Therefore, I have declared a throws clause to the public static void main saying throws IO exception. You can refer to the source code of this example from Java Virtual Guru. Here is an example of file copier. In this example, I have also imported a file output stream. In addition to file input stream and two exception classes, file not found exception and IO exception, as you see at line 1 to 4. In this example, in addition to file input stream, I have also created a file output stream object passing a command line argument, as you see here at line 25. Further, at line 40, I am reading a byte and writing the same to a file output stream object. Here is the code. You may take this code from Java Virtual Guru and then try simplifying the same by creating the objects of both file input stream and file output stream in the same try blocks. I have kept them in different try blocks to keep it simple for your better understanding. Filter input stream and filter output stream provide no additional functionality, but serve as base class for input stream and output stream wrappers, such as data input stream and buffered input stream. This implies that they are used for wrapping other input stream and output stream objects, such as file input stream and file output stream. Two commonly used subclasses of filter input stream are data input stream and buffered input stream. Both data input stream and buffered input stream cannot be directly used. They are used for wrapping other input stream objects. If you have noted in the earlier examples, we have wrapped the file input stream to a buffered input stream. And filtered output stream is subclassed by data output stream and buffered output stream. Data output stream and buffered output stream also act as wrappers to other output stream objects. You will soon see an example on how to use these classes.